All right, let's begin with today's session. Indefinite or definite integrals and right-hand and left-hand limits. So I'm just really touching indefinite, indefinite. I'm squeezing it into one session or one slide to just briefly summarize what you would have done in year 11, and then really try to talk a bit about right-hand and left-hand limits, because I think what happens is that you learn how to integrate, and yes, you do know how to integrate. Yes, you know it's the area under the curve. When you anti-diff, that's what it means. Instead of the gradient, you know it's the area under the curve. And a lot of times, the very start of the chapter, which is the right-hand and left-hand limits, it doesn't make sense. Like, you know, okay, one tells you an overestimate, one tells you an underestimate of the area. But you're like, well, I don't really need it. Yeah, and it's the concept that you need. You might not apply it as often, but it's the concept that I want to go through. Okay, so let's have a look. This is all area study 3, all the dot points that we're covering through here. And mainly the one I'm talking about just now is this dot point, where you're talking about the definite integral as a limiting value of a sum involving quantities such as area under a curve. And that's the one that I think a lot of students will take for granted, which is the reason why the last question I'm going to choose for you, 17% only got it right that year. It's because of that dot point. So a lot of people understand how to anti-diff. They'll understand indefinite and definite, which is the second last and third last dot point. And then properties of antiderivatives, I think that is also taken for granted as well, which is why it comes up in your exams. So those 4 dot points are your main ones. Otherwise, you probably know most of it anyway. Okay, so let's start off with our understanding right-hand, left-hand estimates, right? Now, let's take it for granted at this point. In the next few lessons, I'll then talk about fundamental theorem in calculus, which is why the area under the curve is actually the antiderivative. You've just taken it as information that we've told you. We've told you that the antidiff is the area, and you've taken it for granted. Okay? Let's just say that we still take it for granted. Then that means in these both equations here, where I have y equals x minus 1 and y equals x plus 1, it's a straight line. And let's say I want to find the area under the curve between 1 to 3. Okay, so we know that that means the antidifferentiation, the antidifferentiation of x minus 1, which I'm going to write out the symbol so you can see. What we'd normally say is we say antidiff between 1 to 3. Remember the small number being the lower boundary, 1 to 3 of x minus 1 dx. Okay? And in this symbol, I want to describe it. That's exactly what I really want to talk about, that x minus 1 dot dx. Why do you always have to have the dx? What does dx actually represent? What does it mean? And that's the whole point of this right-hand and left-hand estimate. Okay? So we know that we want to find this area right now. Let's say you didn't know how to use the techniques, how to anti-diff yet. Then what you would do is you look at that shape and you say, oh, that's a triangle. You've got a base, 2, and a height, which is this point here. You would say that is f of 3, tells you the height. So you'd say f of 3, subbing 3 into the equation, 3 minus 1 is 2. So I know that this triangle has an area half base times height. Okay, so we know it's 2 units square. And so these ones are pretty easy, even if I move the graph up. So it's still a gradient of 1, but I've moved the graph up. So you've got a 1 set at 1 versus a negative 1, right? I move it up. I still have that triangle, except the difference now is I've got a distance with a rectangle. So to find the area, you'd either split it up into 2 shapes, find the area, or you find the area of a trapezium. So pretty straightforward, yeah? The problem comes when it is a curve. When you have a curve, it's an issue because now you can't use your geometrical shapes, your triangles, your rectangles, and your trapeziums. So if I gave you a shape like this, for example, okay? Because it's a curve, the issue is that we're going to say, all right, let's do the only geometrical shape that we like at this point that covers most things is a rectangle. So we're going to say, all right, we can find the area under the curve by, and this is what they call the left end and right end estimates. So we're going to estimate the area, let's say between 2 to 5. So from distance from 2 to 5, I'm going to split it up into a certain amount of rectangles. Okay, why rectangles? I know the area of rectangle is half, I mean not half, it's length times width. Now the width depends on the number from 2 to 5, which is a unit 3 distance. There's a 3 units difference. The number of triangles, the rectangles that you have depends on the number of rectangles you want to split. So the interval 3, I could either split into 2 rectangles, which makes it like that. Okay, I can have this rectangle, and I can have, this rectangle. Okay, so that's 2. But obviously, if I do that, then there's more of an area of error. See, I have this area of error that doesn't account for it. So obviously, logically, it makes sense. The smaller the width of the rectangle, the more accurate the area would be, logically. Okay? So I'd say the width here would now, if the distance was 3, this is 1.55, and this is 1.5. And you can find the height by substituting your x values at 2 and 5 to find out f of 5, which is the height, and this is f of 1, which is the height, right? Now, the logic here, what we're talking about here is we're saying, okay, so we've got certain number of rectangles. In my case, I've split it up into 0.5s. So I said the width is 0.5, so it'll be 2.5 here. That's 3, 3.5, 4, 4.5, and I've got 6 rectangles. That will give me an area under the curve if, and if you notice the rectangles from 2 to 5, when I draw my rectangle, I'm going to make sure that starting from this end, if I draw my rectangle, the right end touches the curve first. That's why we call it the right end. Okay? Alternatively, if I wanted to make it the left end rectangle, then it will look like this. Wait, where is it? Why isn't it coming out? Oh, it didn't come out. My animation's gone off. All right, well, I guess I have to go backwards. If I wanted a left end rectangle, then I'd still have the point starting from 2. My rectangle would actually, the left end of the rectangle would touch it first. And then every left end on the rectangle. And what you can see is I'm getting an overestimate of the area. You see, every time I hit that curve, I'm drawing my rectangles, and you can see I get an overestimate. So the left end gives an overestimate if the graph is dropping down. If the graph is decreasing, what you can see is that I get an overestimate. If I do a right end, then I get an underestimate. So for both of them, they're both wrong in terms of its accuracy, but we said estimate. We're estimating. So what they said is, okay, so what I'm going to do is, I'm going to say, one gives you an overestimate, one gives you an underestimate. What happens, what if I reduce the width of each rectangle so infinitely small that it becomes really accurate, right? And depending on the curve, so as the curve goes up and it goes down, I will vary whether it's left end or right end. Okay, so I'm going to vary the width, so I can say from here it could be left end, left end, left end, and then at some point I think it should be thinner and it'll be more accurate, and then maybe over here I'm like, yeah, that's all right, I'll take a width and I'll do right end. So I'm going to vary left end, right end, and this, if I sum all this rectangle, if I found the width, multiply it to the height, because that's the coordinates of each point, gives you the height, and I sum all those rectangles, that will give me the best estimate or theoretically the exact area under the curve. Okay, now having said that, that means you can summarize this idea. And this is the key concept that was for the last question I'm going to get you. So I want you to look at this equation and really understand what this is trying to say, because if you understood it, you will be able to do that last question that 17% of the state couldn't do. And this idea. This is the idea. All they're saying, what I just described to you is summarizing the symbols here. When you do that summation symbol or integration symbol, this just means sum. So this means sum. Sum between A to B, which is your distance. It's your interval from A to B. The question is, I asked you at the start, I said, why do we write that we have to have dx and we have f of x? That literally is just a description of what I told you to find the area of each rectangle. So for each rectangle, if you think about it, this is what it's doing. You're saying the width, which is the change in x, that's a width. And let's say this coordinate right here, whatever that x is, which in our case is 2.5, it will be f of 2.5. That will give you the height of this rectangle. So it makes sense that you would say height, or the area of this R1, area of R1 must equal to f of 2.5, which is the height, multiplied to change in width, which in our case we know it's 0.5. That will give us the area of the first rectangle. This is what that's saying. This is just saying width multiplied to height for every point of x. This is exactly the same thing in the next part where it says equals to limit of change of x approach 0. This is exactly the same thing as what I'm saying over here. This is just saying that the width or the change of width is approaching 0, meaning I'm going to make it infinitely small. I'm not going to make it 0. The width of the rectangle is not 0. I'm making it approach 0. It's very similar to your first principles. We're saying if the width is infinitely small. Yeah.
Why is it a sum from 1 to n?
1 to n, so the 1 to n represents the number of rectangles that you've divided by. So if the distance is from here to here is 3, then the more rectangles you have, obviously the more accurate it is. So they said if you divide that by n, so you're starting from the first rectangle to the nth rectangle.
But yeah. Why is it the difference of sums? 1 to b minus 1 to a.
Difference of sums?
Yeah. The sum of all the rectangles that you make is 0 and b. Let's subtract that from 1 to 0.
I'm not understanding what you're saying. So you're saying, why is this not the sum?
If I write the limit of the expression, the sum from I is 0 to I, but the n is integer because they're adding into the rectangle.
Yeah.
Why is it infinity?
Why is it infinity?
Yeah.
Um,
Don't we shrink it into the decimals?
Oh, so you're saying like that. Why isn't it like that? Is that what you're asking?
Yeah.
Maybe, I'm not sure. I've always interpreted it as n as a value that is finite, that we know. But I guess in that expression, if you said it's infinite, maybe you don't have an answer? Maybe that's why? I'm not too sure actually. N to me, I've always interpreted as being so large that you've got very, very small width of the rectangle, but it's not equal to 0. So I suppose maybe I do interpret it as an infinity sign, but n normally would tell you it's the 6th or 100th rectangle is what you're talking about. That's how I sort of understood it. But yeah, I wonder if that would still make sense if I put I is equal to 0 and then n being infinite.
I think the ones that it's just some large n.
Yeah, there's some large n is what we're saying, because the larger the n, the more accurate the area would be, and I guess that's what their definition is trying to say. Okay, so what I'm trying to say there is just you've got your f of, depending on which rectangle you're talking about, is it the first one, second one, third one, and this is just the change of width for the first one, second one, third one, depending on the number of rectangles you split it into. So if you wanted 2, you would have done the width divided by 2. If you wanted 3 rectangles, divided by 3. So that's what your n is. The n tells you how many rectangles you have. Okay? Now, the reason why I emphasize this is because this just tells you sum of all rectangles from A to B is the area under the curve. That's all I'm saying. So when the question comes up, I do want you to read that. Remind yourself that it is just saying the area under the curve between A to B. That's the key step. Okay, very simple concept, but that's all it's asking. Okay? Now, having said that, so now we understand that to find the most accurate, or the way to find the area under the curve, is we're going to find this infinite sums of rectangles, left and right end. Combination of the both will give you the most accurate one. Okay? Having said that, we understand that now, so that we can say, for these examples, you can have a look at my PowerPoint slide, but the idea is just there'll be some questions in exams where they ask you to use the left end or right end to find the area, and all you're doing here is you say width of 1.5 times the height, which we know is f of 1, and they would have given you the function for you to figure out. Okay, now let's move on to some basic year 11 integration or anti-diff revision. Okay, so you got your first function or formula. This is anti-diff of any polynomial. A to the power of x x to the power of n, the anti-diff gives you this formula. Now, all of you who've done special would know this back to front now. And if you didn't know that, this is just the opposite of derivatives. Whatever you did for derivatives, you're just doing the opposite right now. So if you think about derivative, if you had y equals ax to the power of n, what you would have done is you would have said derivative dy dx is equal to n multiplied to ax to the power of n minus 1. So instead of minusing 1 now, if you want to go backwards, of course you add 1, because you minus 1. So if you add 1, it brings you back to where you were before. Instead of timesing by n, then of course you're dividing. But because you times it first, then you have to divide it by what you removed. Because remember, when you bring it, when you do, let's say, x cubed. Oh, that's okay. I think it lagged. For example, if you did y equals x cubed, and I asked you to find the derivative, you'd say it's 3 times x squared. It makes sense that if you add the power by 1, that will be equivalent to this 3, which is why we say instead of timesing, we will now divide it by 2 plus 1, which is the same thing. These two will cancel out. That's why you're reversing the process. That's why it's undoing the derivative. Okay, so you understand that this is just undoing the n that you multiply, and this is undoing the power that you subtracted. Okay, so you got your anti-diff formula now. Notice there's a c, and that's the difference between indefinite and definite integrals, which I'll talk about in the next slide. And here's the second part that I want you to pay attention. These are properties of your integration, which you will use to do some of the past exam questions I'm going to show you soon. The sum or subtraction or sum or difference of your integration inside, you can actually split it up into two separate functions. So I'm saying that you can have anti-diff of 3x minus x squared, and you can do this by splitting up the integration between 3x minus integration of x squared dx. That is possible. That's what I'm saying. That's one of the properties. And the properties here is proven through the previous slide that I showed you, the right hand and left hand area. So they've been able to show that property. Same thing if you're multiplying k, which is a constant, k to your function, you can take k out as a factor. Okay, it's a dilation factor, so you can do that. That's all it's saying. So I'm just saying here, for example, if you have 3x anti-diff of 3x, then it's the same thing. You can write it as 3 times anti-diff of x dx. It's the same thing. Okay, so you got your properties, you got how to anti-diff. So you got how to anti-diff, you got your properties, and the next slide, it is just a quick revision. Let's go! My examples here is just trying to show you. First property, you can take out 3, that's a constant. So it's a dilation factor, you can take it out, so that's what I've done here. X to the power 5. Now the rule says you will add the power by 1 and then divide that depending on whatever the power is. So in this case, I will be saying this is the same thing as saying x to the power 5 plus 1 over 5 plus 1. That's the anti-diff formula. Don't forget the c. Okay, so if I do that, what you can see is this now gives you an answer of 3x to the power 6 on 6 plus c, but the 3's will cancel out to be 1 and 2. So we've got the answer is half x to the power 6 plus c. Okay, so that's your anti-diff formula and using the properties there. Same thing I'm going to use for the second one. I'm going to split it up because it's plus, I can split this into 3 different intervals. Again, I've taken 3 out as a common factor, oh, not a dilation factor. Integrated each one, so same thing again. This is going to be plus 1 over 2 plus 1. This is plus 1 over negative 2 plus 1. And integration, remember, even though you don't write an x, this is the same thing as writing x to the power of 0. So it will be 0 plus 1 over 0 plus 1. So if you follow that, what you can see is you'll get 2 plus 1 is cubed divided by the 3. But because you're multiplying by 3, the factor of 3, that's why it cancels out. And then you got your negative 4x negative 1, and then 3x to the power 0 plus 1 is 3x. And that's how I get my answer there. Okay? And same thing with the next one, the bottom one. You can always refer back to the PowerPoint if this is going a bit too fast. But you got your negative 3 as a constant, and I can bring x to the power of 5 up. So 1 on x to the power of 5 is the same thing as writing x negative 5. That's what I've done here. Okay, and then use the anti-diff formula again. You got negative 3 multiplied to x negative 5 plus 1 over negative 5 plus 1 plus c. And that's how I got my answer as that. So this is like a crash course on last year's stuff on integration you would have done in Spesh. Now the difference between, you know the inverse now, you know how to do that. Plus c is always for indefinite integrals, okay? And indefinite means that you don't have a distance between a to b. When you find the area, you don't know if it's a to b. You're just saying in general, what is your area formula? This will tell you the actual area. Okay, so definite integral will tell you the actual area. Indefinite integral doesn't tell you, it just tells you a function. Okay, that's why you have plus c. Now logically, why do you have the plus c? It makes sense because if I gave you y equals x squared minus 1 and y equals to x squared plus 7, and I asked you to find the derivative will give me dy dx equals 2x. So that means if I asked you to find the antidiff of 2x, it's the reverse, then which one is it? Is it minus 1 or is it plus 7? That's why we don't know, and that's why we write our answers as x squared plus c, because we're not sure what that constant term is. That's why you always have to have the c. Okay? Now, definite integral, this is the one where I'm going to explain the theory. You've taken it for granted, but I'm going to describe this theory in the next lesson. Fundamental theorem of calculus is this idea. And that's where it all came from, like why we know that the area under the curve is actually the antidiff. Okay, right now I'm just telling you that it is, but that's where it all started. Okay, with Newton and Leibniz or something like that. I don't know how to pronounce his name. Leibniz, thank you. And so this is the formula. This is your definite integral. All you're saying is, if you want to find the antidiff or the area under the curve between 2 points, then you still find the antidiff as you normally would. But because it's between a to b, the formula says you are going to find out what it is if you substitute b into the function, which is what this is. So the upper limit minus the lower limit. Now over here I've done the, as an example, let's say antidiff of 3x squared. We would say it's 3 times, and that's 2 plus 1 over 2 plus 1. And you got your plus c. Fair call. So the answer becomes x cubed plus c. Yeah? So that's indefinite integral. Then when you go to definite integral, it's exactly the same thing, but let's say I went from negative 1 to 1. Okay? Negative 1 to 1. The only difference is you still get x cubed plus c, but because you're going to subtract each other, the c's actually cancel out. That's why we don't write the c in the next step. So you got your x cubed here, and all the formula is saying is you're going to sub 1 into the function, subtract sub negative 1 into the function. So all I'm doing here is I'm saying f of 1 subtract f of negative 1, which then now becomes 1 cubed minus negative 1 cubed. That's what we're doing. Okay, that's what this whole step is really talking about. It's just saying sub the upper limit in, subtract the lower limit. This will give you the definite integral, which is the area under the curve. So we solve for that, that just becomes 1, and that's minus minus 1, so you get positive 2. And that just gives you the area. If you had to picture this graph, 3x squared, looks like that, negative 1 to 1, it just means the area under the curve between negative 1 and 1 is equivalent to 2. Okay, that's all they're saying. It's 2 units squared. That's all you needed to know for today. Like today, that's what I want to revise just quickly for the year 12s, and then for the year 11s. So this is quite a bit of a rush for you to take in. So do listen to video today again and have a look at my PowerPoint slide. But for all of you, you should then be able to do the next 3 questions using this understanding. Okay, so here's the first one. I think this was just about 47% of stay getting this correct, and it's the same idea. If you understand what I was talking about, the right end, left end estimate as the area under the curve, you should be able to answer this question with no troubles. Okay, you can use a calculator if you want, or you can do it by hand. You're going to do this one, and the second one, I think it was again same thing. It was about it was just 51%. So most students got it. It was above 50, but still I think that was pretty low for a question that was easy. And the last one, 17%. So there's 3 exam questions. Have a go with this one. I'm going to give you 2 minutes, and then we're going to look at the answer and like what approach you would have done and what understanding you've taken out of this. Okay, so read the question. It says a part of the graph, you've got x squared, is shown below. Find the approximate area, which is the estimate, of the shaded region by drawing rectangles as shown in the second diagram. So they've drawn the second diagram. Zoe's approximation is, and I guess the only hard part here is not finding the area under the curve, but to find it as a percentage. P percentage more than the exact value of the area. So the question, what is the exact area of the curve, and how do you find the percentage of that it's more? Okay, so already in your head you should be forming a technique on what you'll be doing, how you're going to approach it, and then it might just be a bit tedious writing it down or solving it by hand. Okay, so let's have a go. 2 minutes, so it's 10:10. Give you 2 minutes. But I'm excited for the last question, because if you get the last question, it should take you 10 seconds. Bam, you get your answer. Otherwise, you'll be sitting there and you have no idea what you're doing. Well, State had 17%, so I'm like, well, it says a lot about how much we understand. About 30 seconds left. And time. Okay, let's say if you're still working on it, that's okay. I just wanted that the approach, you knew what you had to do. The approach obviously said that you want to find the percentage. This is the exact area. That's your exact area. So what you have to find out is, well, what percentage more than the exact area? So you need to know what the exact area is. And the only way to find out this is the antidiff of x squared, because they told you it's an x squared function, between 0 to 6. That's a definite integral approach. So I know the antidiff of x squared, which we know is x cubed on 3, so x cubed on 3 between 0 and 6. Put that in. So you got, you know that when you sub it in, 6 cubed on 3 minus 0 cubed on 3. This is the fundamental theory of calculus to find your definite integral. 0 cubed minus 3 will cancel out. So you just need to know what 6 cubed divided by 3 is. And 6 cubed, I think that's 216. And 216 divided by 3 is 72. Okay, so the area is 72. 72 units squared. That's the exact area. Now I want to know how much is this more than the actual area. Now it's pretty easy because the width of the rectangle is all 1. So the height of each rectangle is at each of these points here. This is the height. So for this rectangle, it would be f of 6. But since the function is x squared, then at x equals 6, you get 6 squared. So really, you're just adding f of 6, f of 5, f of 4, f of 3, f of 2, f of 1. Times by the width. Sum all those rectangles together. Well, it just becomes f of 1, which is 1 squared. F of 2 becomes 2 squared, which is 4. F of 3, which is 9. F of 4, 16 plus 25 plus 36. Okay, if you sum all that together and then subtract from 72, you will find how much more, or the difference, the area is. Find our percentage. It's how much more divided by your exact times 100. So that's the approach, right? That's what you would have done. So, and the second one, they actually show you the technique that you would have done. So you would have found out some of them all gives you 91. Found the area 72. 91 subtract 72 tells you the difference. And then times by 100, that gives you 26%, so approximately 25. So your answer was D. Okay? I mean, not D. Yes, it is D. 1, A, B, C, D. Yes, that is D. This just tells you the number of students who left it blank. So 0% left it blank. Yes? It's 25. So 26% is, yeah, it's closest to 25%, which is D. All right. Now, next one. Question 14. This is now hitting on properties of antidiff. I want to reduce this down to 1 minute so we have time to look at the last one. Okay. Let's go with 1 minute. This is using the properties. So I told you before, I wanted you to focus on that slide. I said, watch out for the properties. Yeah, I said the very first start of the slide, I said the 3 things is the limiting value, understanding the properties, understanding the left and right end. Those are the important ones that they generally test because students don't focus on that. They know how to antidiff, but they don't understand antidiff. And time's up. The very first approach, when I said using properties, the first thing you should notice that you can split this up into two separate integrals because of that plus sign. And just imagine these brackets weren't there. Then the nice thing about that is you can then take out 2, using the properties, you can take that out as a dilation factor. And so the nice thing is they already told you, they said antidiff of 1 to 4 of f of x dx is equal to 2. So I already know this equals to 2. That's 2 times 2. So in my head, I already know there's 4 plus whatever the definite integral of 1 to 4 of 3 is. Now the definite integral of 3 is actually equal to 3x1 on 1, which is the same thing as saying 3x. And you want it between 1 and 4, which is why I got this. And you answer the question, sub 4 in, 3 times 4 is 12, and then minus 1 sub 1 in, and that gives you this next step, which is what I wrote here. So subbing 4 in, that gives you 12. Remember fundamental theorem of calculus? 12 minus sub 1 in 3. So 12 minus 3 gives you 9. And then 9 plus 4 gives you 13. So your answer is E. Okay, so answer is E, and 51% of them got that correct. So I thought that was a straightforward properties question. Even though it was above 50, that's not really that high anyway for an easy question. Now, you have 4 minutes, which I'm doubling the time, for you to have a look at this last question. Don't be intimidated by the symbols. Read it, interpret it. It's all about interpretation. Okay, don't give up just by reading all these symbols. Okay, so have a look at this one. 2003, question 17. Don't be intimidated by the symbols or notation. Read what it's trying to say, because if you get it, you should be able to do it in 10 seconds. Okay? So don't be intimidated. Remember that property I told you before. I said, try to understand what this is really just asking. That's the one I was trying to explain to you. So read it, and you really understand it. You just need to interpret it. If you interpret this, it makes so much sense in what it's trying to say. It's just written mathematically difficult. Can I get a show of hands for those who think they definitely know the answer? Alright, cool. This is a good start. I'm going to try to just break up what the word's been saying here. Okay, so you've got, find from the interval 0 to 4. So in your mind, you've got 0 to 4 of some graph, some curve, 0 to 4. It's divided into n equal sub-intervals, which is what I said. I said to find the area under the curve, you're going to split it up depending on number of rectangles. So right now you don't know how many rectangles you are. You're going to split it up into a certain amount of rectangles, right? So in my head, this is what I've got. I've got from 0 to 4, I've got rectangles. Okay, I don't really care what they look like. I just know it's rectangles. And they say that points x0, x1, x2, x whatever goes on to xn, which really this just represents x0, x1, x2, x3, which is just your points or values in terms of your width, depending on number of width. Okay, that's all they're describing there. And then the next part, which is here, they said 0. This is just the interval. They're just saying that x0 is larger than, it's equal to 0, and it's larger than, sorry, it's less than x1, it's less, so it just gets progressively larger. That's all they're telling you. So all in this whole line so far, all they've done is they've just described the x-axis. They've just described 0 to 4, the numbers from 0 to 4, one is larger than the other as you increase x1, x2, x3. Yeah? And then they say, let the change of x, which is the width, the last one minus the previous one. So each one you're minusing. So they're just telling you the width. They're just saying in that description there, they're just saying it is the width of these rectangles. So far, they haven't told you anything besides the fact that it's from 0 to 4. That's all they've said. So The key part is here. Which you remember I said this interpretation is the same thing as saying from 0 to 4. Notice that they use this. This is xi, which is your height, which is your function. F of xi is actually apparently equal to xi. So really they're just saying it's x, sum of all your functions, x which is the function, first one or second one or third one, doesn't matter, multiplied to the change of x. Now if I actually just took all that out, all those symbols out, I'm just asking what is the area of a straight line equation x between 0 to 4. That's literally all the question's asking. So because it's just a linear function and it's just f of x equals x, from 0 to 4 you can picture already. 0 to 4, width is 4. Well, if it's x function, this has to be a height of 4 as well. So the area is half base times height. 4 times 4 is 16, divided by 2 is 8. The answer is E. So what was really hard about it? It wasn't the mathematics. It was the interpretation. It goes back to the one concept that I was trying to get you to understand. Okay, so if you look on the next slide, that's what they tried to describe. 17% chose that answer. The rest tried to, 33% of them tried to do the integral and representation, so it's just described there. But I thought that was a nice one, just to really test the basic understanding of integration. Okay, so you can have a look at that again. I'm going to end the video. Look at the video and look at the PowerPoint again if you wish. Okay, it's up on Schoology. We'll call that a day. And I'm done.